thank you for the opportunity to present. I know many of you in the room. There's a real mixture of people here, which I think is very important. We've got town officials, we've got members of the industry, we've got activists, and we have people that are just interested in local control. And this is an issue that really has been a challenge to all of us in the last 5 to 7 years. I've been asked to give a summary of some of the experiences that we've gained working with industry to meet the state reclamation standards. So a long time ago, when I was dealt this hand, I learned that there were no good guys or bad guys, and there aren't any easy answers. And as Tom noted, there are many different perspectives, but this is an issue that we're all working on, trying to do our best. The first thing I want to do is just show you this cartoon, because there's been a lot of discussion about industrial sand, quarries, and then sand and gravel. In the background, you'll see a bedrock control landscape, we'll call that sandstone, with some spoil piles and some product stockpiled. In the foreground, you've got a hole in the ground, which is more sand and gravel with a stockpile. And in between it, you'll see some agricultural production going on. My point here is that if you don't mine it or grow it, you don't produce it. It's just a reality. So the other point I want to make is that from the first caveman, land management and mining and water management go hand in hand. It either runs off or goes in the hole. In either way, it's a problem. So these are just realities. Our mission is to encourage stewardship for sustainability. The thought there is that you need to use the resource, but you need to manage it wisely so you can maintain it, and it's to support a quality environment and a productive economy. So it's a very balanced circumstance. And as Tom noted, as a public servant, I'm obligated to stay in that position. What I'd like to do is just give an overview of the outline today. I thought I'd talk very briefly on the geologic setting, which has everything to do with local issues, local control, local decision making, and the local environment. I'd like to give you a little bit of background on the regulatory framework, then update you on what the mining and reclamation process actually is, and introduce a reclamation study that we've contracted River Falls to do, working with industry to start moving into a more deliberate reclamation in this part of the state, and then close with a few big picture lessons learned. There are some hard facts. The environment's where we live, there's no denying it. The land base is used to support the local economy. Agriculture, forest, mining, tourism. This was brought up earlier. Mining and processing are extractive in nature. There's no way to sugarcoat it. You are destroying the land, you're consuming the water, and then you're planning to rebuild the land and rehabilitate it. State law requires that non-metallic mines be operated and reclaimed using standards to limit environmental impacts and achieve post-mining land use objectives. About 15 years ago or longer, the environmental community and the industry came together and agreed that we needed a non-metallic mining reclamation law in Wisconsin. This was pre-industrial sand mining. It came out of an understanding that the sand and gravel industry was not reclaiming land, and we were leaving these brownfields all over the landscape. And there was an agreement by the industry and the environmental community to put something together that would assure the land was reclaimed. Another hard fact is that non-metallic mining and processing industries are important contributing sectors of the state's economy. Steve touched on this, and will continue to exist in the long term. Certainly, outwash is used by the aggregate industry for infrastructure. for cement that goes into our foundations and our buildings, and also to maintain our roads. And then we have sandstone now that is used for industrial sand, and we're anticipating that that's going to be used to drive some of our oil exports, natural gas. Steve noted the importance of the not only local economy but national economy. While we're dealing with this current downturn in oil prices, Congress is on the verge of approving a removal of the ban on allowing export of crude oil. So we're going to be going into a full-blown competition with the rest of the world on producing natural gas and oil. Right now we're importing oil from the Middle East as well as producing it here, but just anticipate that in the long run, as long as we're making diesel and natural gas, there's going to be a demand for oil. And finally, the quality of site reclamation will determine the quality of the post-mining environment. And that's what I'm going to focus on today. In some areas of Minnesota and Wisconsin, sandstone formations occur at or near the surface. And the main formations are St. Peter, Jordan, and Waniwak. We're mining the Jordan and Waniwak here. And these formations will provide a stable supply of industrial sand. This is the map you've seen. You've seen that golden crescent that extends across western Wisconsin and into Minnesota. And importantly, if you look at a cross-section down at the bottom there, you can see the different layers of sandstone. And the reason that we're seeing the development of industrial sands in western Wisconsin is because this is where the Waniwak deposit and the Jordan occur right at the land surface, and it's able to go there. You're able to go there and mine without having a lot of overburden, so it's very cost effective. This is the map showing the development pattern of the industrial sand mines. And my point here is that it's all local. It's all about where these deposits are and how they're being managed, both by the companies and by the local municipalities. The key point is that each mine deposit and mine operation is unique. The location of the site and the physical characteristics of the geologic deposit affect the pre-mining soil types that are occurring on that landform, the land cover, and the land use. Now I didn't want to be too provincial. I'm going to show you how things are happening in Chippewa County. But in calling my colleagues around the state, I was very surprised to learn that there's a lot of mining being done in different locations in the landscape under different land covers. In Chippewa, we're mining wooded ridges, but in other parts of the state, Jackson County, Trumpewa County, other places like that, they're actually removing farmland from production and then mining deposit there. So depending on where you're located, it affects a lot of not only what your pre-mining land uses are, but what your post-mining land uses may be. The local location of the site, the physical characteristics affect mine architecture and operations. And I'll get into this in a little bit more. Some mine deposits are simply going to be more cost effective to mine than others. And as we entered the boom phase, it was early in, try to get your market share under top prices, and that's what drove the boom. But as we move into another economic time, the locations of these mines and their efficiencies will determine who's going to stay in business and who's not. And then the location is going to largely determine what the post-mining land use and reclamation potential is, and I'll go into that. And finally, it's going to determine what the reclamation needs and challenges are, and they're going to be unique to each municipality. So by that I mean it's very important as you live in a local municipality to work with the mining companies to define on the front end what you want that post-mining land use to be and the quality of the environment to be when you finish the mining work. Again, recognize that it's all about locality of the deposit. It's about the local locality of the deposit and where the deposit lies in relation to groundwater and surface waters. These are controlling factors. This is a map showing Chippewa County and the pattern of development. We have 12 permitted industrial sand mines. 5 are fully operational and have been fully operational now for about 4 or 5 years. So we're far enough into the program where we've got some experience working with the representative mining companies, and that's part of what I'm going to report out. Part of the reality of what we're dealing with, the regulatory framework in Chippewa County was that we have federal mine safety laws that apply. We have state environmental codes that exist, and I see Rebecca's here from the Department of Natural Resources. These are uniform state environmental laws across the state. And then we have the county non-metallic mine reclamation ordinance that's in place in all locations in the state. In some places we have zoning, in some places we don't. In Chippewa County we have neither town nor county zoning that applies in the towns where the mines are. And then finally in Chippewa County we have a number of towns that have exercised their village powers to develop licensing and developers agreements. So this is the regulatory framework that we've been working under. And importantly, what this has allowed us to do is determine what the safety net can be by just working with the state environmental rules and the state administrative rule for non-metallic mine reclamation. So what's been the county's role during this? Initially, we were responsible for the planning and permitting phase, which started in about 2008 and has run to present. And our paramount role there was to facilitate public participation, to review the plans, and then to permit the development. Later on, as the mining companies came into production, we moved into the production and reclamation phase, which started in 2010 to present. And under that role, we're responsible for permit administration and compliance, both in inspection and enforcement, and then resource monitoring, not only the rate of land reclamation, but what's going on with the surface and groundwaters. I want to just mention very briefly how important the public participation component has been to the development of the industry in Chippewa County. The NR 135 rule was the only state administrative rule that was in place that required an opportunity for public hearings. And if it wasn't for the willingness of the industry to listen to the public and hear what their concerns were about the environment, and the willingness of the public to step forward and identify the scope of their concerns, we wouldn't have had the opportunity to put some of the conditions in place initially to protect the environment that we did. So I think once the decision was made to allow mining in the county, the decision focused then on trying to achieve the highest level of mining protection and the highest level of reclamation that we could possibly achieve. There have been other communities that have chosen not to allow mining. Those were community and politically based decisions. For whatever reason, in Chippewa County, be it through a laissez-faire policy after careful consideration or absolute avoidance of the issues, I'm not sure what drove it, but there was no political decision by the county to intervene, but rather to allow the applications to proceed. So what's the county's role in the ordinance administration to ensure the plans are complete, provide an opportunity for public review and comment, determine if the plan is adequate to meet reclamation standards? I mean, can it actually be engineered? Can mining be engineered to assure that reclamation can occur? That's the test. Act on the permit, monitor and issue compliance, and certify reclamation. In effect, I work with a staff that works with the mining companies, and we're quality control officers at this point. Importantly, reclamation is required to be contemporaneous. You're required to reclaim as you go. And the state standards are performance standards. They're not numeric, which allows for quite a bit of flexibility. And so in dealing with the performance standards, there are requirements for surface and groundwater protection, topsoil management, final grading, and revegetation. There are also general standards. The plan content includes information about the site, physical characteristics, land cover and use, ownership and lease arrangements. In our scenario, the mining companies are, for the most part, leasing the land and from landowners rather than owning the land itself. That has a big bearing on the type of reclamation that's occurring and their capacity to reclaim. Also, importantly, the plan is to identify post-mining reclaimed land uses. And the post-mining land uses have to be clear enough to define the type and intensity of use, and also to include performance measures to evaluate reclamation success. They also provide information about how the operation will proceed, what the mine architecture will be, and the operational phasing, information about material processing and handling, and vegetative planning and management. There's a key point I'd like to make, and that is the post-mining land use targets are defined upfront by the mining companies and the landowners, and this determines the type and degree of reclamation that will occur. Another key point is that many, but not all, first-generation reclamation plans developed for industrial sand mines, at least in Chippewa County, have been broker-developed by new corporations engaging third-party engineering firms. They've been prepared to address immediate environmental concerns, principally surface water discharge and groundwater quantity and quality requirements, and that they've been conceptual and lacking detail on specific types of reclaimed land uses or evaluation criteria and performance measures. We heard often and accepted plans where the post-mining land use was something like, we're going to reclaim to wildlife management areas and we want recreation. Or we're going to reclaim to conservation lands and farming. That was acceptable at the time. We were focusing on some of the more immediate environmental concerns. But in fact, as we get down to the time where we're beginning to reclaim with the producers, we're finding that that's not specific enough to allow us to focus, to really target what our reclamation needs are. So I was very pleased to be invited to this conference. It's a little bit like coming to confession, but I'm telling you, we can do better. So the key point is that the quality of reclamation can be greatly improved, and the public's expectation is that we move from a time when we're just dealing with site stabilization to a time when we're trying to achieve post-mining land uses that have high ecological value or economic returns. The code itself actually says that we're supposed to have criteria for assessing when reclamation is complete and therefore when the financial assurance can be released. And that criteria has to be quantifiable to assure there's not ambiguity in what we're trying to achieve. So in learning our shortfalls in the last couple years, we've begun working with the mining companies to seek more standardized categories for post-mining land use and standard criteria and performance measures that we can begin using to determine when reclamation is actually complete, because we can't be subjective, we have to be objective. So the criteria that we've come up with are site stability, plant density and species diversity, soil chemistry and fertility, soil organic matter, and other proposed criteria as agreed to. So I handed around a table of standardized post-mining land uses that we're beginning to use, and you can take a look at those and see if something like that might be of value or could be refined by others in your community. But importantly, reclamation success will be evaluated probably over a period of 5 to 10 years. Simply getting the site planted is not reclamation. You have to rehabilitate the site and verify that the site can support the post-mining land use that you've selected. So we're moving from this time of just having a site be stable and calling it reclaimed to setting a higher expectation of what we're really trying to achieve ecologically and economically.
Question. Right there.
I'm going to keep rolling, and then I'll come back to you. Thank you. The standardized categories are conservation lands. These would be ones that really have no they have ecological value, but not economic return. Working lands, these would be lands, agricultural production, forestry production, that you're seeking economic return. And then we have developed lands, and those would be your commercial, industrial sites. Importantly, some of those early reclamation plans were generic in what the vision of the land use was. They were very shy on how you get there. That's the purpose of the reclamation criteria. Here's a couple examples. So let's say someone wants to reclaim the grassland prairie as an ecological use. The criteria would be site stability. So you'd look for the percent of erosion that you have over that 10-year period. Ideally, you would have little, and it would get better. You would look at plant density and species diversity. You would select a certain prairie mix. You would look for a percent cover at 1, 3, and 5, and 10 years. And you would also look at the species of that prairie mix that actually survived over that period of time. You might even want to look for bad guys. You might want to look for thistles or prickly ash or other thing that's coming in. You certainly want to take a look at your soil chemistry and fertility. If you're planting a prairie, you don't have to have high pH. You can have very low pH. You can have very low fertility. You can have low organic matter. Much of western Wisconsin before settlement was oak savannas. The Native Americans, Native peoples, burnt that land, kept it open, sustained it. As we look at reclaiming sites, we need to take a look at what our physical capacity is going to be and the best potential for a realistic land use match. Similarly, if you're going to look at aspen production, we might want to look at whether we're going to plant aspen seeds or sprouts, and then how do you evaluate that over a 10-year period to determine whether that's really been successful. There's a lot of potential, I think, using aspen and other fast-growing species to create biomass that would have an economic return. If we wanted to look at ag production, I think it's viable to maybe look at some of these sites for pasture. You'd obviously have to figure out what kind of animal you'd want to be feeding. It's one thing to have a goat pasture. Goats can eat almost anything, including rocks. But if you're trying to grow beef, that's another story. You might have to get your pH up there high enough to sustain some alfalfa. Certainly you want to plant a pasture that you don't have to replant every 3 years. So you need to start thinking in terms of what's your target land use and what's it going to take to get there. I'd like to run through a few slides. Up until a couple of years ago, I was talking about reclamation. I hadn't achieved it. And I want to thank the industry reps for their patience here and for working with us to do some test plot work to determine what it really means to try to reclaim a site. Importantly, this is the cartoon I just looked at, but this is another one. This isn't a cartoon. This is actually a site being planted to a prairie at one of the industrial sand mines in Chippewa. Again, you can see the bedrock control landscape in the background. This is your tailings pile, and this is the product of washed sand. So we have achieved reclamation, and we've learned quite a bit about it. The purpose of the reclamation project by Chippewa County was to demonstrate and evaluate what the reclamation procedures and treatments would be, to determine the type and quality of reclamation that can be achieved, and also to try to accelerate the rate of mine reclamation. Because as we work with different companies, there's no sense in everyone trying to recreate the wheel and go through the learning curve. If we can start doing some test plot work and sharing some lessons, hopefully we can start cooperating to improve the quality of the work. The approach was to seek operators that might have an interest in doing demonstration or research sites. The county would provide technical and scientific support for the project. We would contract non-biased third-party service providers. We selected, in our case, UW River Falls, Dr. Holly Golliver at the Soils and Geology Department, and then trying to learn by doing. Initial interest was expressed by Matthew Construction, who is the largest road builder, or one of them in the state, and they had an interest in looking at sand and gravel operations that were now cropland to determine whether or not they could be reclaimed to agriculture, particularly back to cropland. Superior Silica Sands is an industrial sand mining operation. They're mining bedrock ridges with shallow sands, and they had an interest to see if these sites could be reclaimed to pasture or grassland prairies. This is an industrial sand mine shot from Google Earth. No sense investing in those drones anymore. You can just go to the websites now and get a real close-up look at all the sand mines from any angle you want, and you can monitor progress. But importantly, you'll see that the mine processing site is here. You've got the bedrock ridges, but importantly in Chippewa County, the base of the Wani Walk is right here, and it goes up 80 feet, and that's the target sandstone deposit. We are not in Chippewa County, for the most part, mining agricultural lands for industrial sand. We are siting our processing facilities on cropland and putting some of our stormwater ponds on it, but for the most part, we're not mining the bedrock ridges. And the reason we're not is because there's no soil there. The soil on these bedrock ridges, for the most part, is about from my tip of my finger to my elbow, and then you're into fractured bedrock. That's not the case in many other places, including Barron County, including Buffalo. It's unique to your municipality, and you have to take a look at that. So the idea was to do a demonstration in 2014 and then actually install reclamation test plots in 15 and instrument them. This is the picture of the landscape, and you'll see it's a soil map, and what you've got here are many different soil types on the ridges, but for the most part, they're very limited bedrock sandstone soils. And this also shows the location of where benchmark work was done to determine what the native undisturbed soil physical properties are, and then the location of a demonstration site and a site that would be reclaimed and instrumented would be. A close-up again of the two sites, demonstration and then reclamation. The purpose of benchmarking, and this was very important, was to characterize the pre-mining conditions, the land use, the physical properties, the soil functions and productivity, and to provide a benchmark control that can be used to compare the pre-mining conditions and landscape functions to the post-mining reclaimed landscapes and functions. And the scientists wanted to look at the biological properties, both the vegetative types and diversities, so they're using certain evaluation tools to inventory that. And secondly, to look at the soil properties and functions, particularly the physical properties, soil moisture and infiltration, soil temperature and conductivity, and biological activities. What we know is that these sites, at least these wooded ridgetops, have high soil infiltration capacity and are the source of a lot of the groundwater recharge in the immediate watersheds. So again, the steps were to look at what it takes to strip and manage the native soil and overburden, how the mining operations actually occur, what it takes to return the overburden, to reapply the subsoil and topsoil, to apply any soil amendments, to prepare the seed bed and plant the vegetation, and to establish and manage a permanent land cover. And it isn't easy. Any of you that garden know how difficult it is to get your seed bought and your little garden plot tilled in the spring and then manage it to get your vegetables. It all has to come together. If you were to ramp that up one more notch, think how hard it is to be a farmer and make a living by getting your crops planted and working between the weather and then hoping to get a productive harvest. If you're trying to reclaim the landscape and to get a site restored and planted during the course of a growing season, you also have to deal with all the material handling functions. So it's critical that reclamation be integrated into operations. And what I want to do is just show you, this is a cartoon series of 6 slides put together by Mike Parson at the UW Extension Geological Survey that shows the typical mining operation in Chippewa County and Barron. And what you see here is this is the landscape. You can see the glacial till and a little bit of soil on top, but this is the target Waniwak sandstone. This is some sandstone overburden of another deposit, and this is the water table. So what I'm going to do is just step you through the process that the mining operators should go through. The first step is to strip the stockpile, the topsoil in the stockpile. So that's come off and it's down here. The next step is to remove the overlying sandstone deposit. In this case, it's the Eau Claire sandstone deposit, I think, and they've stockpiled that. Now they can't mine that because it's too impure. So that's part of the material that will be going into reclamation. Then they stockpile their target sandstone. Then they process it. This is the sand. You can see some of the materials, the wash plant materials that are not being used. They get stockpiled. And then we can start doing work here where they're starting to rebuild the back form of the landscape and take some of that soil and re-spread it to begin recreating the landform. And this is what it looks like when you're all done. So then the question becomes, gee, how does this new landform behave environmentally, ecologically, in relation to what you started with? And that's another whole set of questions and concerns that folks are looking into. So again, just looking at it, the site itself, this is the bedrock face. You can see how little soil there is. How do you physically remove that? There are a number of members of the industry here that tackled that differently. But the idea is you want to try to keep as much of that material as you possibly can, because that's the growth media for revegetating the site. You then begin reforming the landscape with the overburden and do your final grading. The next step is to prepare any soil amendments. In this particular case, the people at Superior Silica Sands took some of the wash plant byproduct, the fines from the wash plant process, and they're trying to see if there's any value in putting those down before recreating the soil to see if that might help with the soil moisture holding capacity. Kind of just a little experiment. And then finally you do the site grading and try to plant the site. One thing that we learned is that it's very difficult in working in operational cells that are bigger than 5 acres, because as you work through the spring and summer storms, it's very easy to have big rainfall events that occur while you're vulnerable. And so part of learning by doing was to learn to understand what the optimum size would be of those reclamation cells. The other thing that the companies did is they kept track of the hours and materials and equipment costs of every step of the process as a way of learning how they can become more efficient. In 2015, River Falls actually worked with the company, and they went through the whole step process again and actually reclaimed the site, instrumented it, and planted it to a native prairie. Half of the site gets a soil fertility treatment, the other half doesn't, and of those two halves, half get some of those wash plant fines, the other don't. And this is the photo I showed you earlier. This is the company that was contracted to do this soil work. The company also contracted local service providers to do the tillage, and one thing we learned is how important it is to be timely if you're subcontracting some of this work in between the rainfall events as you're working under a short window. This is Neil Duval from Prairie Nursery doing the initial survival counts, and this will be replicated, and I'll keep an eye on this over the next 10 years, and we're hoping that this can become a baseline benchmark site that others can use as they're evaluating how a prairie progresses on a reclaimed land form. Key point, and I'm going to wrap it up here, but market forces determine the type and volume of materials mined and the rate of mining and reclamation. Non-metallic mine reclamation is integral to mine operations and occurs in phases using operational cells. This first point is the first point it was like an aha moment. We have these reclamation plans that were approved by the Plan Commission in our office, and they were at best optimistic projections of what mine reclamation might look like. What we learned is that these operational plans and reclamation plans are dynamic. They have to be evaluated and assessed on an annual basis. Every year we meet with the mining companies and determine what was mined that year and talk to them about what they intend to do to reclaim in the coming year. So it's not a one-time approval and then you check in 10 years. It has to be hands-on. Reclamation activities occur continuously as part of operations, and that the mining reclamation efficiency is affected by both mine architecture and material handling and processing. Time is money, and as the companies go into a competitive phase of their life cycle, those that are most efficient are going to be those that are most potentially profitable, and those are the ones that will remain open. Reclamation activities occur during a very short seasonal window, subject to weather challenges, and this requires additional resources. It requires additional hours, skill sets, money, and equipment. It needs to be planned, scheduled, and synchronized with mining operations. It's not possible to use slack time on the night shift to do the reclamation. You need, if you're mining full-time and you're meeting contract provisions, the mining companies need to ramp up and put on extra crews to start building mining reclamation into operations. They can only do that after they're into the deposits, maybe 3 to 5 years where they got enough room to operate. Key point, mining significantly alters soil characteristics and properties. It wrecks the structure of the soil. It changes the bulk density and filtration capacities, and it changes soil biology and microbiology. Believe it or not, the soil scientists can put instruments in the ground that measure CO2 flux. CO2 is the breathing of the biology of the soil. I don't know if night crawlers breathe, but evidently other microbes do. So they can measure soil health and activity based on CO2 flux. Management concerns are compaction, that's the common enemy. Creates less infiltration and more runoff. And of course you have to be mindful of erosion. Mined soils must be restored through time and management. It's not enough just to plant them. You've got to rehabilitate them by reintroducing the soil biology, the vegetation, the root structure. Most of the soils in this part of the state are about 12,000 years old. Okay, that reflects 12,000 years of soil development. It's going to take us some time to rebuild these soils to achieve their ecological and economic benefits. Soils are formed and distributed unevenly in the landscape. So if you're leasing, if you're leasing from 5 different landowners and the soils are, let's say, better at the bottom of the slope than they're at the top of the slope, it's very difficult to achieve individual land uses if the soils aren't distributed evenly. So this presents a challenge for those that have multiple landowner uses. It's very important to identify those land use targets up front so we're not disappointing anyone. In conclusion, in West Central Wisconsin, we have limited practical experience in reclaiming these landscapes. There are notable exceptions. Our friends at Badger Mining and Fairmont Minerals have quite a bit of experience. The people at Badger Mining have been just super. They've been welcoming and have allowed different groups to come through and take a look at what they've achieved. They've been mining for about 30 years and reclaiming for 30 years. And what we're finding in the test studies being done at their sites is it takes about 30 years for some of these soils to regain their infiltration capacity, even if the soils are just planted to prairies. So it takes a long time. But they're willing to share experiences, and there might be experiences from other locations that are transferable. In Minnesota, they've been mining industrial sands over by Mankato and St. Peter for years. We have a representative from that industry here today. There's information we can learn from what they've been doing. Most of the reclamation experience that we're going to be using is going to be transferable out of Illinois and Indiana, who have similar temperate climates, and they've been reclaiming under coal. Okay? So we'll look there. And then, of course, Minnesota trap rock. So again, in conclusion, each mine deposit and mine operation is unique. The location and the physical site of the physical characteristics of the deposit affect the pre-mining land use, the mine architecture, the mine operations, and the post-mining land use and potential for reclamation. Sites with adequate soils have greater potential to be reclaimed as working lands. If you've got deep silt loams with high moisture holding capacity, you have a lot higher potential to reclaim that land to a productive forest or a productive agricultural use, be it a pasture or a permanent hayfield, or even try to reclaim it to row crop production. But if you're dealing with sites with limited soil capacity, because they're shallow, they're sandy, they have low organic material, you've got a lot more difficult challenge. We allow the landowner to determine the land use target and the target goal, but it's my obligation as a quality control officer to assure that the post-mining land use that can be achieved is done so in a way that is sustainable and non-polluting. So as reclamation has begun, we're learning what it takes. We're learning what the hours, skill sets, and money is to efficiently synchronize mining with operational functions. Tom mentioned people he respects. This is a guy named Dan Murkowski and a guy named Brady Johnson. They're a couple mine foremen at the Fred Weber mine, the Superior Silica contracts. These are really get it done guys. You may disagree with whether or not mining should be done, but just know that many of the mining workers are trained professionals, and they care greatly about their profession and their craft. And these guys are the guys that are going to determine whether or not we have reclamation success. We as a community can set expectations, we as control officers can do inspections, but it's these guys that are going to make it work. And believe me, they want to make it work because it's part of who they are. I got to tip my hat to these guys. So we're at the beginning of a very long journey. Reclamation processes require planning and scheduling and time. I think there's a high potential for success because it's a pretty limited, targeted challenge that we face. If we're going to be successful, we're going to need to commit resources to assure high-quality reclamation that's sustainable and provides economic and ecological value. I'm convinced that not only can we achieve some economic return on these sites, but we have a real upside on the ecological side to create some landscapes that will have high ecological value. And we'll need to build partnerships with industry agencies, the research community, and the environmental advocates. And we're going to need to commit to research, long-term monitoring, and data sharing. Data sharing is critical because, again, we don't all want to go through this stiff learning curve. And I'm hoping that in years to come, we can have conferences like this that are more targeted to industry where we can share notes. So this is my last plug, and it's a plug for local control to ask that we not preempt local reclamation authorities. I think the NR-135 rule is flexible and performance-based. I think it's administered locally with state quality control. And I think when done so in accordance with the other state administrative rules, we can achieve at least land and water level protections. I'm not so sure on the air quality issues. In Wisconsin and Minnesota, we have a very high opportunity here to use reclamation as a way of achieving post-mining land uses if we're clear about what our target is. And if we do not, then we may create sites that are actually liabilities that have negative values. So in my view, it's all about the end game. And again, despite whether you believe or don't believe mining should occur, once the determination is made that it does, then the key piece that we can come together on is reclamation.